Objective 2 is the use of the half-angle formulas to find values. I'm going to rewrite these half-angle formulas for you because we want to get sine isolated. I don't want sine squared, cosine squared, and tangent squared of the half-angle. So in order to do that, I have to take the square root of both sides. So if I take the square root of sine squared of the half-angle, I get sine of the half-angle equals plus or minus square root of 1 minus cosine theta over 2. So there's your first one. If I take and square both sides of cosine squared of the half angle equals 1 plus cosine of that angle over 2, I get cosine of the half angle equals plus or minus the square root of 1 plus cosine theta all over 2. And finally, the third one, once again, take the square root of both sides. I get tangent of the half angle equals plus or minus the square root of 1 minus cosine of the angle all over 1 plus cosine of that angle. Okay? Now, since I have plus or minus, because I had to use the square root property there, I'm going to have either a plus answer or a minus answer. So your answer to these will be positive or negative depending on what quadrant you're in. And what trig function you're looking at. Okay? All right. So let's go ahead and look at what we have here. It says use the information given about the angle where theta is a value between 0 and 2 pi to find the exact values of each of the 6 trig functions. Or it doesn't say each of the 6 trig functions, just the trig function. So let's look at A. A asks us to find the double angle. And we're given some information here. We know that secant theta equals 9. So if secant equals 9, since it's the reciprocal function of cosine theta, if I take the reciprocal 9, I get 1/9. So I'm going to write this out as cosine theta. And before I start part A, I know that part A is going to require me to use this formula. Sine of the double angle equals 2 times sine theta cosine theta. So I need both cosine and sine's value. The other thing I need to know before I start this is what quadrant I'm in. So if cosine is positive, because it's a positive 1/9, and sine is also positive, the only place that happens is in quad 1. Okay, so all my values are going to be positive. So when I use the half angle formulas, I'm going to write a positive square root or whatever. Okay, but we're not there yet. So let's look at A. First things first, draw yourself a triangle. Okay, so cosine is adjacent over hypotenuse. So the adjacent side is 1, the hypotenuse is 9. I have to find the missing side. So I'm going to use Pythagorean theorem. 1 squared plus x squared equals 9 squared. So 1 plus x squared equals 81. X squared equals 80. X equals the square root of 80. Now, if I go ahead and write this up, I know this is going to be 4 times 20, and 20 is 4 times 5. I can rewrite this equaling 4 radical 5. Okay, so I'm going to go ahead and write that out. 4 square root of 5 is that missing side. And if you need to write down the Pythagorean theorem work, please do so. I'm going to be erasing it right now. Okay, so I have all my information, and now I'm ready to go ahead and do part A. So part A says I have to take 2 times sine theta. Sine is opposite, which is 4 radical 5, over the hypotenuse, which is 9. times cosine, which is 1 over 9. Now when I multiply that out, I get 4 times 2, which is 8, square root of 5, and that's times 1, so it's just 8 square root of 5, over 9 times 9, which is 81. And I can't reduce this down, so this is my answer for part A. Part B asks us to find the double angle, cosine 2 theta. Since I was given cosine, I want to use the equation that has cosine in it. Once again, I'm just being cautious. I can use one that has cosine and sine, but I really don't feel like working with the 4 radical 5 in the equation. So if we go back up to the top and we look through the 3 formulas, we see that there's the third formula, which is number 4 here. It says 2 cosine squared theta minus 1. So that's what I'm going to use. So 2 cosine squared theta minus 1. Okay, so I'm going to take 2 times whatever the cosine is, which is 1 over 9 in this case. I'm going to square it, and then I'm going to subtract 1 from that. So squaring those terms, I get 1 over 81. That was gone by taking 1 squared, which is 1, and 9 squared, which is 81. And I'm going to multiply that by 2 and then subtract 1. So this becomes 2 over 81 minus 81 over 81 when I find a common denominator. And then if I take 81 minus 2, I get negative 79 over 81. And that can't be reduced down. So that's my answer for part B. Okay, now part C is asking me to find sine of the half angle. So theta divided by 2. Okay, so I'm going to use a formula. I'm going to use a positive portion of the formula because I'm in quadrant 1. And the formula states that I have 1 minus cosine theta all over 2. Okay, so I'm going to plug and chug underneath that radical. Underneath that radical, I'm going to plug in 1 over 9. Okay, so I get 1 minus 1/9 in the numerator over 2. Finding a common denominator, it's going to be 9. So 9 over 9 minus 1/9 all over 2. So working that some more, I get 8 over 9 because 9 minus 1 is 8. And the denominator is 9 over 2. Okay, working some more. I'm going to take it down here. And I'm going to turn this into multiplication. So 8/9 times 1/2. Okay. So if I reduce this down, I can say 2 goes into 8 4 times. So I now have underneath the radical 4 over 9. Now breaking that up, I get square root of 4 over the square root of 9, which equals 2/3. So my answer for part C is 2/3. Okay, let's do D. D is asking us to find cosine of the half angle. So cosine of the half angle. So once again, we have the square root of, and I'm going to put a line here just to kind of get this off. And remember, it's positive because I'm quadrant 1. And this is going to be 1 plus cosine theta over 2, but let's double check. And now I'm going to plug and chug. So cosine's value we found by using the triangle, or actually it was given to us, is 1/9. And that's all over 2. So I'm going to take 1 and turn it into a common denominator. So I'm going to have 9 over 9 plus 1/9 in that numerator underneath the radical over 2. And then I'm going to take the square root of 9 plus 1, which is 10 over 9, all over 2. And now I'm going to turn this into a multiplication problem. So 10/9 times 1/2. We're going to reduce this down. 2 goes into 10 5 times. Once I get that done, I get the square root of 5/9. So if I break that up, I get the square root of 5 over the square root of 9. So I get the square root of 5 over 3. And that is the answer for part D. Okay, moving on. Find the exact value of cosine 22.5 using the half angle identity. So the half angle identity, remember, they're always written out, like cosine in this case, of theta over 2. So we need to find theta. Okay, so we can write this out. Cosine of the half angle equals 22.5. Or let's just deal with a half angle. If I want to isolate theta by itself, all I need to do is multiply both sides by 2. When I do that, I get 22.5, and I multiply that by 2 to get 45 degrees. So theta equals 45 degrees. So if you have a problem like this, just double whatever angle you're getting, and I just showed you why that's the case. Okay, so cosine of 22.5 degrees is equivalent to cosine of 45 degrees divided by 2. Okay, so now that I have it in the form of cosine of an angle over 2, I can use the formula. Now, 45 degrees is in quadrant number 1. So my result will be positive. Okay, so I'm going to use a positive square root, and I have 1 minus cosine theta. Actually, I think this is a plus divided by 2. So double check. 1 plus cosine theta. Yep. And now I'm going to plug things in. So if we plug this in, we get 1 plus cosine at 45 degrees, and this is all over 2. So now evaluate. So cosine at 45 degrees is square root of 2 over 2, all over 2. I have to find a common denominator in that numerator under the radical. So 1 becomes 2 over 2 plus the square root of 2 over 2 over 2. And now let's make this a little bit better. So I get 2 plus the square root of 2 over 2, and that's over 2. Now I need to turn this into a multiplication problem. So I have 2 plus square root of 2 over 2 times 1/2. Now I can't cancel anything out because 2 plus square root of 2 is a binomial and 2 is a monomial, and I can't cross those out. They're not the same. So I'm going to write this up as 2 plus square root of 2 over 2 times 2, which is 4. And now break it apart. So the square root of 2 plus the square root of 2 all over the square root of 4. Square root of 4 simplifies down to 2. So in the numerator I have square root of 2 plus the square root of 2 all over 2. So that is the answer, and I know it looks weird, but that's the answer for this example. So let's go ahead and move down to the next one. It's telling us to use the half angle identities again, and they're giving us sine of 112.5 degrees. I want this to be in the form sine of some angle divided by 2. And that has to equal, that some angle divided by 2 has to equal 112.5. So remember, I told you to do these problems, you just double the value. So 2 times 112.5 degrees equals 225 degrees. That's in quadrant number 3. So sine is negative in quadrant 3, so my result will be negative. Okay, so when I use this formula, I'm going to have a negative in front of the square root. So if I write this up as theta being 225 degrees divided by 2 equals negative square root of 1 minus cosine theta all over 2. Okay, so I'm going to plug in chug. So negative square root of 1 minus. Now cosine in quadrant 3 is also negative. So cosine of 225 is going to be negative radical 2 over 2. So if I write that out, I get 1 minus negative radical 2 over 2 all over 2. Okay, so a negative times a negative is a positive, and also I have to find a common denominator. So I'm going to do that in this step. So negative square root of 2 divided by 2 plus radical 2 over 2 all over 2. So this is kind of like the last one. So negative square root of I get 2 plus radical 2 over 2 all over 2. Turning this into a multiplication problem, I get 2 plus radical 2 over 2 times 1/2, and that equals negative square root of 2 plus radical 2 over 4. Now rewriting this, so I have a radical in the numerator. The numerator is going to be 2 plus the square root of 2 all over the square root of 4. So I get, as my answer, negative square root of, I forgot to move the pen like this, so let me do that again. 2 plus square root of 2 all over 2. So this is the answer for this problem, and once again it was negative because I was in quadrant number 3. And finally, this last example, and I think it's the last example, yep, it's the last example, I'm going to simplify the trigonometric expression by distributing cosine x first. So let's distribute. So if I distribute that, I get 2 cosine x sine x, and then plus cosine squared x minus sine squared x. Okay, now I'm looking to use substitution. So 2 cosine x sine x looks really familiar because that is sine of the double angle. So I'm going to go ahead and substitute that in. So I'm going to make a little note that I use substitution here. So this is sine of 2x. Now, cosine squared x minus sine squared x is also a formula from this section, and we're going to go find it. So if you look at the half angle formulas, which don't work, so you keep on moving up to the double angle formulas, and you'll see that we have, with example number 2, cosine squared theta minus sine squared theta equals cosine of the double angle. So let's go back to that problem. And substitute that in. Okay, so voila, there you have it. That is simplified. So that's taking that big long expression and simplifying it down to that. And that's the end of this section. So you guys are done with 8.6.